Hi, I'm Nidhi from Think Global Education Services. Today I'm going to take a small demo on the topic combustion analysis. It comes under mole concept or stoichiometry, very well known topic. So here I have a question here. An unknown hydrocarbon is composed of carbon and hydrogen. Combustion of this fuel produces 11.26 grams of carbon dioxide and 5.77 grams of water. Determine its empirical formula. Now, how to proceed for such questions? Combustion analysis means whatever is the hydrocarbon of the fuel, we are burning that in excess of air to produce carbon dioxide and water. Since it is composed of only carbon and hydrogen, so after combustion we will get oxides of these two elements. If I have any other element, I will get oxide of that element as well. Here only carbon hydrogen are present, so I will get CO2 and water as the product. Now, since it is a complete combustion, in complete combustion, number of moles of carbon are equal to number of moles of CO2 produced. Why? Because we are burning the compound completely, so how much or whatever is the amount of carbon in the original sample, it will convert completely into carbon dioxide. That's why if we can calculate the number of moles of carbon dioxide, we can calculate the number of moles of carbon present in the original sample. So, according to our data, the mass of carbon dioxide produced is equal to 11.26 grams. Now we know number of moles is equal to mass in grams divided by molar mass in grams per mole. Now for carbon dioxide it will be which will give me value equal to 0.2558 moles of carbon dioxide. Since mass of moles of carbon is equal to moles of carbon dioxide, so therefore moles of carbon is equal to 0.2558 moles in the original sample. Now, if we can calculate the number of moles of hydrogen in the original sample, we can work out the empirical formula also. So, if I have n number of moles of water, then I will have 2n moles of hydrogen in the original sample. Because why? Because water is having 2 moles of hydrogen atoms. 1 mole of water is equal to 2 moles of hydrogen. That's why if we multiply the moles of water with 2, we can get the moles of hydrogen in the original sample. Here in this case, mass of water is equal to 5.71 grams divided by molar mass of water, which I will get as 0.3202. So moles of water is equal to this much. Now if I want to calculate moles of hydrogen, I have to multiply this value by 2. Two times moles. That means this value will become these many moles of hydrogen. Now if we have to calculate the empirical formula, so if I write carbon here, okay, I will just write them again. This is carbon, this is hydrogen, this is moles. So for hydrogen I am having 0.6404 moles, and for carbon I am having 0.2558 mole. If I get the simplest mole ratio now, in that case I have to divide the number of moles with the least number of moles available. Here least number of moles are moles of carbon. So I will have which will be equal to 1 which will be equal to 2.5. 2.50. Now since I don't get a whole number here for hydrogen, I have to convert this number, this ratio into a whole number ratio by multiplying it with a suitable integer. In this case, since it is 2.5, if I multiply it with 2, I will get 5. So I am multiplying by 2. So I will get for carbon 1 into 2 is equal to 2. For hydrogen 2.50 into 2 is equal to 5.0. On this basis, our empirical formula will be C2H5. That is the empirical formula. Now in the same question, if I continue, if we take a part B of the question, which asks that if molecular mass of compound is 58.0 grams per mole. Now, what is the molecular formula? In this case, first I will calculate the empirical formula mass, which will be equal to 29 grams per mole. Now I have to do just one very small thing. I have to check the ratio between the two. So the ratio between the two comes, if the formula I can go accordingly. Molecular mass is equal to empirical formula mass times X, where X is equal to a whole number. From here, this is 58.0 and my empirical formula mass is 29 times X. So I get value of X is equal to 2. So to find out the molecular formula is equal to empirical formula times value of x. Here x is equal to 2 and my empirical formula was C2H5 times 2. It becomes C4H10 and that is the final answer.